So virtual reality has kind of found its way into most of our lives. It's being used for a variety of industries already, some quite sophisticated. We've also found it in national sports. We had a group in once to show us how second string quarterbacks who don't get enough time out on the field are being trained through VR to develop muscle memory for what happens when a tackle's coming right at them to sack them. So the virtual reality in the medical area is not new, but using kind of haptic response, feeling the results of your virtual experience, kind of sensing what the kidney feels like when you poke it, that is kind of new. And Fundamental VR is a group that's deeply in this area, meant to help people in their surgeries, but also to, if you cannot get a cadaver at your university, this is kind of one alternative. We're going to set up a couple of their systems right outside the front door here, just off to the left, for you to experience. You can go over there and do an appendectomy if you'd like. But before we do that, we're going to demonstrate it with Richard Vincent, who's the CEO and co-founder of Fundamental VR, and Danielle Hernandez, who's a digital science editor at the Wall Street Journal, are going to demonstrate it for us right now.
All right, welcome.
Hi.
If we can pull up the first slide, that'd be great. And Richard, what are we looking at here?
Well, so what we're looking at here is the hardware end of fundamental surgery. Fundamental surgery is a software as a service education and rehearsal system in virtual reality. And what we see here is a surgeon using it.
Bit, just so it's a little louder.
Yeah. What we see here is a surgeon using it within the clinical environment. The arms that he's holding in his hands, we have them here, they provide the haptic feedback, so the sense of touch. He's obviously within a full virtual reality space, and he's rehearsing a particular procedure. In this particular case, he's actually doing a pedicle screw procedure, which is the placement of pedicle screws into the vertebra as part of a spine surgery.
And why is that haptic feedback important as you're trying to use this to train surgeons or medical students?
Well, it's essential. So surgery, now I'm not a doctor, I'm a technologist, but I have a great medical panel around us who tell me that surgery is at least 50% touch. Often you can't see the patient, often the area where you can see the patient, you can't see the area you're operating on, so you need to use touch. And so haptics are essential to really create a full simulation.
And to create that full simulation, I imagine there's a lot of data involved. Can you just quickly walk us through some of that?
Yeah, there's kind of two parts of the data really. One is in the formulation of the haptics, so extracting from our medical panel what it feels like to interact with different tools onto different tissues, how they feel, react, and are stimulated, to extract that, to encode it, and then seal it so that we can use it within the programming. And then the other part of the data story is measuring everything that's happening within that simulation. So where you're looking, how your efficiency of movement's working, which is a good indication of capability, how your patient's outcomes are being recorded, and doing that over a period of time. So creating a data dashboard that for an individual is really useful for their learning and development and ongoing capability. But at an industry level starts to surface some really interesting mega trends around surgical capability over the long term.
So maybe we can move to the system now, but what kind of surgery am I going to be performing today?
Right, so today we're going to take a look, thanks Pete, we're going to take a look at what's called a anterior hip replacement. So we've, and apologies if anyone is a little bit, it's a representation of the procedure. So this is a part-through procedure.
Okay.
If you just look down a little bit, we can then see there we go, we can see the patient. So we've already opened up, we've actually extracted the femoral head, so that's the top of the hip bone, and we're now looking at the acetabula, which is the receiver of the hip bone. So what I'm going to ask you to do is to, if I just pass you this tool, so this is our haptic device, and we've added an extra piece to this one, so it feels more like a real, yeah, there we go. like
a real, too soon there.
So this Acetabular Reamer, as it's called, is designed to take the surface off the top of the acetabula there. So if you look into the area there, that's it. And then, now you obviously don't know what you're doing as a non-qualified surgeon.
I have no
So if
medical degree
If you
whatsoever.
look up to the screen, you can see there's some
Okay.
instructions there. So basically it's telling you that you're going to need to ream the acetabula. It's talking about the angles of approach and how much you need to take off it. And perhaps we'll add a bit of a help overlay. So if you perhaps look up to the top left of the screen,
All right.
and there's an eye
Little
there.
eye, okay.
Yeah, click on that. That's
Okay.
it. And now look down to the patient.
Oh,
And we've
okay.
now given you a virtual
Little
overlay.
hologram.
Exactly. So a little additional instruction. So self-proctoring. You don't necessarily need an expert there
Okay.
to explain how to work. And then please feel free to go for it.
And if I just poke the skin a little bit, like, let's see what happens there. Oh, okay. So it
So it
you sort of
deforms
feel a
and
little
reacts.
feedback, yeah.
Yeah.
All right, let's get to the surgery, though. How much time do we have?
You've got a couple of minutes. You're okay.
Okay.
Right.
Very fast surgery here.
Okay, so the key thing here is as you ream acetabula, you feel the resistance change. It starts to go smooth.
Okay.
So you'll feel that as you start to push through. So if we didn't have the haptic feedback, we wouldn't have the ability to do that. Please go ahead.
Should I go for it?
Yeah, go
okay,
for it.
let's see. So you really feel like you're drilling. I'm not a builder either, but I feel like this was something like that it would feel like.
So you just look down a little bit.
Okay.
There you go. Perfect.
So the texture's starting to change a little bit. Why is that?
So as you're starting to ream through, it's smoothing off the surface, and that's what you're feeling for, that smoothing effect. And once the texture goes quite soft, then you're really complete.
I think I'm done. It's a little bloody in there.
Okay. So if you perhaps take
It's
that out.
a little bloody over here as well. Okay.
So we would manage and measure all of those movements, and how efficiently you put that in and out is a signal of your capability.
I think I may have bumped something in there. Probably this patient might not walk after the fact.
So let's have a look at what you've done.
Okay,
so if
so
you
how
look
do I
up
do
to the
that?
screen again,
Okay.
bottom right, there's a little
Check mark.
checkbox.
Okay.
Click on that,
Okay.
and then look up at the screen, and it will give you an assessment. Let's see how you've done.
44.
So we forgot to take an X-ray.
Oh, should we do that?
So let's have a
Put it
quick
back?
X-ray. Yeah, pop it
Okay.
in, and let's have a look at the. So we use the X-ray to look at position. So if you look over to the X-ray.
Okay.
So this is a real virtual X-ray that's now giving you that exact position of where you are. You
Okay.
make an assessment on that, and then
How does that look?
looks
Oh, I
slightly
bumped
off, I
the
think.
flesh there again.
And then, so you're about 4 degrees. Like, you know what? For a third attempt, that's actually really not too bad. So that's pretty good.
Maybe I'll go to medical school.
It's certainly possible. There we go. And the idea with this. So let me take that off you. There we go.
Okay, all
And then
right.
perhaps if you take the VR headset off,
Okay.
we'll take you out of that environment.
Back to
free from that.
reality.
Well done.
Thank you.
Well done. Very efficient. And yeah, so as you said, in medical school, within the operating environment, within the surgical environment, having this very low cost equipment, and this is a sub $10,000 piece of hardware, available on a day-to-day basis, we think is essential going forward because it just allows repeat practice and rehearsal.
Who's using it?
So we're partnered up with the Mayo Clinic, and we have it installed into the Mayo Clinic, and we're also co-developing with them. And around the world, places in Australia, Zana in Germany, in UCLA, in UCLH in London, and it's starting to roll out now. So, and as well as that, we're also working with a number of device and pharmaceutical businesses to help to accelerate their teaching of their devices. Some of the other speakers talked about the challenges of kind of instilling new procedures into hospitals. I think this is a great way to do that.
So we have a very data-focused audience, I'm sure. Is there any data that shows that this is better for training purposes?
So we're at early stages with that. Validity studies are key. We've done a couple so far ourselves, which we've published onto our website, which show some great efficacy in early stage. There's been a number of studies done across the last 5 or 6 years on looking at different types of virtual reality with mixed results, but generally a positive one. I think the key thing is most of those have not had the haptics. And removing touch from a surgical rehearsal such as that, you imagine trying to ream that acetabula without being able to feel when you got there. Suddenly you're relying fully on sight. It's kind of a game then rather than an actual simulation.
And so you focus mostly on ortho right now, or are there other surgical regions where you're going into as well?
So we launched in orthopedic. We're now working in general surgery with our partnership with the Mayo Clinic. We're also in some of our private versions of the system working in eye surgery, in laparoscopic, and moving into robotic as well.
Okay. Yeah, and so there's a lot of interest in using VR to train robots. Could this be used for training surgical robots based on surgeons, real human surgeon skills?
I think so, over time. I think the short answer is yes. Wherever it's complex and challenging and expensive to do it in the real world, I think this environment offers a great opportunity to do that. What we're seeing in robotic surgery is not just the new skills that you need to acquire and learn, but also as you charge towards the new robotic skills, you need to know the old school way of doing it. And the opportunity to learn, let's take open surgery, just good, simple, general surgery that's open. The opportunity to practice that within a surgical environment reduces as you start to move into laparoscopic and into robotic. So we're actually offering kind of both ends of the spectrum. How to do it if things go wrong and you need to revert to the old way, plus also how to use the new system.
And I think we're done right there.
Richard, Daniela, thank you very much for the demonstration.
Right.
Daniela.